Hello everyone, my name is S.K. Karthikeyan, Associate Professor, Kongunadu College of Engineering and Technology. Today we are going to see friction drives, that is brakes, in the subject of kinematics of machinery. So brakes are nothing but a device that going to produce artificial frictional resistance. So it may, for example, we going to slow down or stop a rotating member means we going to create a artificial arrangement for the member. So that device is known as brake. So it's a mechanical device by means of which motion of a body is retarded for slowing down or to bring it to rest by applying artificial frictional resistance. So there are number of type of brakes you have in the slide. You can see the first one is block brake, that is classified into single block brake, double block brake. So the second one is band brakes, that is divided into simple band brake, differential band brake. The third one is block and band brakes. Then fourth one is internal expanding brakes. Today we are going to see example problem in pivoted block, that is shoe brake arrangement. So you can see the arrangement. There is a pivoted block or shoe brake shown in the figure. So it having a lengthy handle that is pivoted at the one end. Here you can see O is the pivoted point for the lengthy lever. The lever also having a shoe portion in the middle that is rested or pressed against the rotating drum. Here you have a drum like structure that is shaded with the blue color. You can see that that is the thing we going to slow down or stop. So we going to apply the lever. So the brake portion, that is shoe portion, going to having a contact with the drum area and make them to slow down or completely stop by means of a friction. So here we are considering some terms, that is R is radius of the drum, Rn is the normal reaction of the block, and F is the force that is applied at the lever end, and mu is the coefficient of friction, mu Rn is the frictional force, and Tv is the braking torque. So normally in that type of arrangement we are asking braking torque calculations. So here we have a shoe that having a contact with the 2 theta area. So normally before going to the exact problem, you have to do one thing, that is whenever they have the 2 theta angle is more than 40, you have to find one more mu dash, that is one more mu, that is coefficient of friction. So that is the thing you have shown in the figure. So pivoted block, that 2 theta angle is more than 40 means we have to find equivalent coefficient of friction. That having a unit formula, mu dash is nothing but 4 mu sine theta divided by 2 theta plus sine 2 theta. Here mu is normal coefficient of friction, that is actual coefficient of friction. So when the 2 theta is more than 40, you have to go for finding one more mu, that is equivalent coefficient of friction, that is denoted by mu dash. Then coming to the example, this is the example we are going to see for this arrangement. A single block brake is shown in figure. The diameter of the brake drum is 180 mm and the angle of contact is 60 degree. If the operating force is 400 Newton is applied at the end of the lever and the coefficient of friction between the drum and the lining is 0.3. Determine torque that may be transmitted by the block brake. So they are asking the torque, braking torque they are asking. Tb is the thing you have to find. So they have given the diagram. So you can see the diagram. In the diagram having a lengthy lever that having a pivoted portion at O, and at the end of the lever they are applying 400 Newton force, and the shoe having a contact with the rotating drum. The drum diameter is 180 mm and the 2 theta is here we got 60 degree, that is more than 40 degree. So we have to find the equivalent torque also. So coming to the given data, you can see D is diameter of the brake drum. From that you can find the R, that is radius, that is 180 divided by 2, 90 mm. You convert all the thing into meter because you're going to find the torque value. Torque should be in Newton meter. So you keep all the thing in meter. So 90 into 10 power minus 3 meter. And coming to the theta, 2 theta equal to 60 degree. So 60 degree, you convert the thing into radian. So 60 into pi by 30. By multiplying pi by 30, you get the value of 2 theta in the radians. So pi by 3 radians is the answer. Then F, that is the force that we are applying at the end of the lever, that is 400 Newton. Then the final data is mu equal to 0.3, that is normal coefficient, actual coefficient of friction, that is 0.3. So from this arrangement we have to find the TB value. Then the first step is you have to find the equivalent coefficient of friction, because the 2 theta value is more than 40 degree. So you can use this formula, mu dash equal to 4 mu into sin theta divided by 2 theta plus sin 2 theta. So already we have found 2 theta in terms of radians. So you can substitute that thing in the equation, that is 2 theta pi by 3. The remaining things, sin theta means we have the value of theta, 2 theta as 60, so theta as 30 degree. So you substitute whenever you have the value of, you have the formula sin theta means there you substitute the angle. And when you have 2 theta like terms in the formula means you substitute the value in radians. So finally we got mu dash as 0.313. So you can see there is not much more difference. Mu is 0.3 and mu dash is 0.313. Then coming to the next step, after finding the mu dash, we go for finding the braking torque. So before that we have to find the reaction, normal reaction in the arrangement. So Rn is the term that is considered for normal reaction or force on the block, and mu dash Rn is the braking force. So you take the moment about the fulcrum point. So we have to consider some arrangement, that is downward forces are equal to upward forces. So from the point O, you consider everything downward and upward. So in the downward we have 400 Newton that it acted downwards. So that is at the end of the lever. So vertical force into horizontal distance, 400 into 250 plus 200 up to the fulcrum point O, plus mu dash Rn, that is the braking force that acted towards down. So that you added with the 400 Newton. So these things are acted downward. Then coming to the upward, you have the normal reaction Rn, that is vertical force into horizontal distance. Vertical force is acted in the brake shoe portions, Rn, that is 200 mm far away from the fulcrum point O. So vertical force into horizontal distance, that is the moment. So force into distance, Rn into 200. You do the calculation, you keep all the Rn in one side and remaining in the next side. Finally you got Rn as 993.3 Newton. Then coming to the braking force calculation, you have the formula, that is mu dash Rn. You do the calculation, 0.31, mu dash is already we have found 0.313 into Rn, just now we have found 993.3. You do the calculation, finally you got 310.9 Newton. Then coming to the last question, the last question is braking torque. So mu dash Rn into R is the formula, that is force into radius. So mu dash Rn is the braking force into radius of the drum. You do the substitution, you keep the R value in the meter, you substitute in the equation, you finally got TB as 27.98 Newton meter. So that is the required torque that is transmitted by the block brake in this arrangement. So likewise we have to find the braking torque and braking force and mu dash, that is the equivalent coefficient of friction in the given arrangement. I think you have understand all the thing. Thank you.